Oh yes. Oh my god, I agree. Let's go. Let's do it. I like that. I think I already have one of the questions done actually.
Never been on social media. That's easy. That's so.
I never trust this reliable battery pack.
If you're you wouldn't even use it. Exactly. Sometimes like 20 minutes, you feel like 8 hours. Or like
I never trust this battery pack. Bro, I put the battery like and then once when I need a block so and then when I unplugged it, it just kind of didn't want to turn on.
I was really overanalyzing Snapchat last night. I was like, some people use it, some people don't. I use it too. I don't care what anyone else.
Good morning, ladies and gentlemen. How are we doing today? Wonderful, wonderful, wonderful. I give you all that and I get good. Good. Thank you. Thank you. Thank you. Thank you. Sure. If I have any. 50-50 chance.
We should play a game, Mr. Brand. I was on TikTok last night and the last video I saw Remember the Mars and I was
All right. Take a look at the question of the day and start thinking about your answer, ladies and gentlemen.
Yo. If anyone says it's good to see social media, then there's something wrong. There's something wrong.
Olivia. Faith. Steven. Thank you. Irving.
I like it as a person.
Jaden. Josh.
Do today. Alright, it's gonna be a lot. Yep. Oh.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19.
They donated money.
3, 4, 5, 6, 7, 8, 9, 10,
It's like, oh, I don't want to see you people here too. Next week is just week.
Yeah, no, I'm gonna dress up as a freshman.
Yeah. Because my brother. Oh no, were you in? Were you in on the same?
All right, ladies and gentlemen. So, if you had to, would you give up being able to see your friends again, or would you give up never being able to use social media again?
Never use social media.
Never see my friends again.
So there you guys go, friends.
Yeah.
I was beginning to think it would be a win-win for all involved in that case. But anyway, ladies and gentlemen. So, Eric, you would give up social media?
Yeah.
Yeah? You're not a big social media fan?
Low key, nah. There's too much drama on there.
Too much drama on there, yes. And if you have friends, there's no drama with them ever.
Eric, you're the only person I know that
Oh my gosh. I only post like NFL and that's it. Relax.
So Eric is the social media child.
Oh, no, not. Stevie, why are you?
He's a what?
Bro.
I screen.
No. I don't like phones. I don't even have a phone.
Shenza, why are you giving up social media?
I don't use much. I don't even have my friends on my social media.
So you don't even have friends on social media?
Yeah, I have friends in real life, but I use social media.
I use Discord.
Oh yeah.
Social media, I don't need it either, ladies and gentlemen. You can keep your ghost chat and your snap book and all those other things. There's absolutely no reason. Faceagram, that's a good one too. I think my wife uses that.
I feel like you use Facebook.
I use Faceagram.
You use Faceagram? No.
Unfortunately.
What do you use Faceagram for?
I don't know. I just.
What's that? What does this mean?
You're scrolling on TikTok.
Oh.
The funny clock app.
How dead is your computer?
Not even. Not.
How much time do you have? 59. Well, he was at 1%.
Because Friday.
His actually. What do you want me to do? You should fix it. Okay, I will. Bring a charged computer. Problem solved. Well, then don't play
Angel.
other things.
Angel.
You want like a cord one if you want to switch seats? You plug it in.
All right, ladies and gentlemen, today we got to get you ready for
Test.
Come on, you.
one of the last two things on your test, ladies and gentlemen. So, yes, let's do that on Friday. That's a great idea, Stephen. I love that idea. Let's go with that. Let's take that and let's run with it.
I did not say that.
What?
I did not say.
That's what I thought you said. I'm sorry. Did I misunderstand it? What did you say?
I didn't say.
What did you say?
I didn't say anything.
Well, you know what? When you get old, you hear things all the time. It's okay. It really is. It's all right. The voices that are in my head are still talking to me fairly good. So, all right,
Yeah,
ladies and
voices.
gentlemen.
Wait.
Today we're going to talk about what happens when you put a solution in a compound. What? So that you can watch videos of Wisconsin football and stuff?
No, I don't want to do
Well, so you can watch videos of football games and things like that?
this. The EISN slide.
Oh, how much is left on your computer?
I got 19%.
I got 33.
Oh, you got plenty. You're going to make it through the day. Don't even give me that. Okay, ladies and gentlemen, so here we go. We're going to talk about what happens to compounds when we put them into solution. Now, we've already talked about this. What are the two things that can happen if you put a compound into a solution? They can dissolve and become what? Become a gas? Become a solid? They can become aqueous. Aqueous. Okay? Now, if they don't dissolve, what happens? They what? They precipitate. They stay a solid or they become a solid. This was the whole purpose of our final exam in the first trimester. We looked at mixing chemicals together to see if their products would stay aqueous, dissolve in water, or if they would precipitate out, ladies and gentlemen. That is what we were doing with that. Okay? So I need you to get to the slide on ionic compounds in water in your notebook, ladies and gentlemen. For me, it is slide number 34. I would hope it is the same for you. Now, the other thing that you need, ladies and gentlemen, is you need the reference sheet, the pink reference sheet that has double replacement reactions on the top, ladies and gentlemen. On the back side, it has single replacement reactions. Yay! Good. I love the enthusiasm. Love the enthusiasm.
I cheated on Yeah, totally. Oh my God, Morgan. How dare you?
Okay. Hey. So there are two possible outcomes, ladies and gentlemen, which is determined by using your solubility of ions reference sheet. Number one, a compound will be insoluble. Insoluble means that it will not be able to dissolve. That means that it will stay a solid and go and sit on the bottom of your solution. Okay? So that is one of the possibilities that can happen when you put something into water. It may not dissolve. or if something is formed while already in water, like in your lab, it will precipitate out. It will become a solid. It will not be able to dissolve, and it will go sit on the bottom, indicating that there is a solid in your compound. Okay? And you put an S by that. Now, the other option is your compound will be soluble. That means that it will dissolve in water and it will be aqueous. However, if your compound is a soluble ionic compound, what that really means is that it is going to break apart into the ions that make it up. So we haven't talked about this yet. But what really happens when you put an ionic compound into water, and the reason it's ionic is because when you put it into solution, it literally breaks apart into the ions that make up the compound. And we indicate that by putting an AQ by the compound. Okay? So, again, on this chart, we have already shown you how to determine if something is a solid or if it is aqueous. Does anyone have any questions on that?
You should just go over it really quick. These are refreshments. Please.
Well, if you remember, ladies and gentlemen, when we did this, there are 3 different areas to your chart, ladies and gentlemen. There is the area that is at the top. If you put something with nitrate or chlorate, I don't care what you put with them, they're always going to be aqueous. There is no common cations, no common positive ions, that when you put them with nitrate or chlorate, that it will make a solid. It will always be aqueous. Okay? That is the top section. The middle section is the area where normally things are going to be aqueous. So with acetate, almost any cation will be aqueous with it. However, if you put it with silver, it will precipitate. So in this area, ladies and gentlemen, these anions with most things will be aqueous. However, if they are with these few exceptions, they will become a solid. In other words, they will settle out, they will go to the bottom, they will not dissolve. Okay? And in the bottom section down here, ladies and gentlemen, these are normally solids. With most things, they will be solid. However, there are a few exceptions that will make them aqueous. Now, again, cations of group 1 and 2 mean the positive ions in group 1 and 2 of the periodic table. Do not include hydrogen in there. It is not a cation. So lithium, sodium, potassium, rubidium, cesium, francium, beryllium, magnesium, calcium, strontium, barium, and radium. Those are the exceptions that these things will still be aqueous with, and ammonium. And ammonium. Now there is a double exception down here at the bottom, which is carbonate and phosphate will normally precipitate unless they're with ammonium and the cations of only group 1 now, not group 1 and 2, except for lithium. Now you can ask me 1,000 times why it is this way, and it really doesn't matter because this is what we know happens. It isn't a matter of we wanted this to be true. This is a matter of this is what is true. Okay? So there must be something about lithium, probably the fact that it has very few electrons around it, that cause it to, when it is in there, it still ends up being a precipitate with those things at the bottom. Questions? So that is how we use that chart. So you would be an insoluble ionic compound. Are compounds that will precipitate. In other words, they will stay a solid. Okay? So for example, if we put silver chloride into water, it's going to stay a solid. It is not going to dissolve. On our list here, ladies and gentlemen, chlorine with silver will be a precipitate. Whether you try to take this solid substance and put it into water or it gets made well in water, it will precipitate out. So what will happen to it when you put it in water? Not a darn thing. It will stay a solid. That's what it will do. If you put lead sulfate into water, lead 2 sulfate into water, ladies and gentlemen. Here's sulfate. It is normally aqueous, except with silver, lead 2, barium, strontium, calcium. So it will precipitate as well, meaning this is what will happen to it. It will stay this solid. It will stay together. Nothing happens to it. It goes and it sits on the bottom of the container. Okay? If it's made by taking 2 things, one that gives you lead, one that gives you sulfate, and putting them together like in the lab we did for the final exam, then it will make a solid and it will settle out of solution. Okay? There are what are called soluble ionic compounds, compounds that will be aqueous. These compounds will break apart into the ions that make them up, the anion and the cation. So for example, ladies and gentlemen, if we take silver nitrate and put it into water, this is what actually happens to it. It breaks apart into silver ions and it breaks apart into nitrate ions and it floats around in your solution. Now we don't care that it does this, but this is what it actually does. It literally breaks apart. So now when you take and you put some other chemicals in there, that silver ion can go looking to replace something. Why? Because it's already floating around in the water. That nitrate could look to replace something, but here's the thing, nitrate will never do what? Nitrate will never make a what? A solid. So it doesn't matter what the nitrate is with, the nitrate is going to stay like this, floating around the whole time. It doesn't change into anything different, ladies and gentlemen. It stays this nitrate. Now, I don't break up this group. This is the anion, NO3 minus 1 charge, Ag plus 1 charge. This is the way I write them. You leave off the charges, it's wrong. Because these are ions in solution. They are not atoms in solution, they are ions in solution. And to be an ion, you have to have a charge. Lead 2 chlorate. If you put it into water, it's going to break apart. It's going to break apart into lead ions and 2 chlorate ions. Why 2 of these? So it's balanced. Thank you. This is a balanced chemical equation. This breaks down into this and this. 1 silver, 1 silver, 1 NO3 group, 1 NO3 group. That's a balanced chemical equation. Yes, it's just showing it breaking apart, but it's still a balanced chemical equation. Here is the same thing. 1 lead, 1 lead. 2 of the ClO3 groups. So I've got to account for 2 of them by putting the number that was down here, saying how many groups, as a coefficient in front. 2 ClO3s. Charge plus 2 here, minus 1 there. Questions? Everybody remember how to do the plus 1 charges?
Yes. Control and then the period.
Thank you. Control and the period key. How do you do the 3 by the O?
Controlling the comma.
Control and the comma key. Control and the comma key. Okay? So what if we take sodium phosphate and put it into water? And by the way, ladies and gentlemen, okay, We know nitrate, we know chlorate, nothing will be a solid with them. They will always be aqueous. But our last one was phosphate, PO4. PO4 is normally a solid, unless it happens to be with the cations of group 1, except for lithium, or if it were with ammonium. Well, sodium is in group 1. So therefore, it will stay aqueous in water. Now, the 3 by the Na goes in front here so that we balance it off. 3 NAs, 3 NAs. 1 PO4 group, 1 PO4 group. Charge on Na plus 1, charge on PO4 minus 3. Questions? Aluminum sulfate. Sulfate. Normally aqueous, unless with silver, lead, barium, strontium, or calcium. It ain't with any of those. Okay, so that means it's going to break apart into aluminum ions and into sulfate ions, SO4. How many aluminums? 2 of them. How many SO4s? 3 of them. You'll notice I don't need to put the group in parentheses anymore. Why? Because I'm not putting a subscript by it, I'm putting a coefficient out in front. No reason to put the group in parentheses when you're breaking it apart. Questions? I think there's still some people finishing up the typing, so I'm giving them a minute or 2. Anyone need more? Never mind. Still see some people working. Anyone need more time still? We're good? All right. We'll talk about ionic equations tomorrow, ladies and gentlemen. What that means is you have a very big chunk of time here. Now, I did not give you much time yesterday to work on percent composition problems. I did not give you much time the other day to work on molar mass problems. They are all in your packet, ladies and gentlemen. Again, you want to waste your time, take your chances that you can get the 3 major questions on the test, right? Go ahead and knock your socks off, ladies and gentlemen. But if you're looking for problems like you are going to see on your test, here's formula determination problems, this worksheet. The first 4 are empirical formulas, the last 6 are molecular. If you can't do the first 4 and the last 6, you're going to have problems on your test. Because that's 2 of the 3 major problems on your test, probably worth about 31 out of the 40 points that these problems do.
You said the first 4?
First 4, last 6.
Oh, yeah.
First 4 are empirical, last 6 are molecular. Then the worksheet after it, ladies and gentlemen, on percent composition, that is the other major problem on your test. 9-point problem there. The other questions, ladies and gentlemen, right before this worksheet, the ones at the end here, okay? where it's asking how many milliliters would 25.8 grams of chlorine gas occupy. There will be 4 questions similar to this, where it is a 2-step. You are not going from grams to moles or volume to moles. You're going from grams to milliliters. You're going from milliliters to atoms. There will be 4 problems like that on your test, ladies and gentlemen. 4 problems like that on your test. Okay? You have got time to work on them. If you need my assistance, raise your hand. There is something set up in the lab, so you cannot go back in the lab and work, ladies and gentlemen. You can pull a bunch of desks together if you want, okay? But you now have some time to work on things to get done what you need to get done. So, go to work, ladies and gentlemen.
He's in all of these.
Well, you know what's Randy Orton?
Huh?
Randy Orton.
I think he's on A.
I'll be there in 1 second, Morgan.
Hey, Cheeto, did he go to